In this section, we are going to start on domain and range. So we have domain and range. And just like we have said before, we say this function that we say is a machine and can take input. The inputs we say it can take are those inputs that will make it a defined function. Input that will make it a defined function. So it means that it's not everything that can be put into the function. So domain is just like we want to find all those set of numbers that this function can actually take to give us a defined function. So and domain is just, let's just put it, a set of possible value which qualify to be an input of that function. So how do we now find domain? There are some rules in domain that we have to put at the back of our head, of our mind. So it's not something too much. It's just that you should know that when your function is a fraction function, because you can also have a fraction function, your denominator must not be 0. The denominator must not be 0. It means that if you have a function like this, f of x is equals to, let's say, 2x plus 1, whatsoever you are going to have at this denominator, it must be something that must not be equals to 0. So it can be 2, it can be equals to minus 1, minus 2, but it must not be equals to 0. Why is that? Because in mathematics, whenever you have anything over 0, you can try it and press your calculator. It will tell you that it is undefined, or math error, or syntax error, anyone. So it means that anything over 0 is something that we cannot define. You cannot divide something by nothing. You understand? So therefore, you must know that your denominator must not be equals to 0. That's number one. Number two is that if the function you are talking about has to do with square roots, you must not have negative numbers must not be in square roots. And that is what we try to explain when we are talking about how to determine if this is a function or not. So it means that whenever you have something like f of x is equals to, let's say, 2x plus 2, we must make sure that whatsoever this x must be something that at the end of the day we are not going to have negative inside this our square root. All of them we do example of them on them. So another thing we must know is that when you have log, you must not have log 0, and you must not have log of negative number. So I've checked your book and I see that the man did not give you any question on negative log or log of 0. So another thing we must know is that whenever you have a linear function, for example now, you have f of x is equals to 2x plus 2. You have something like this. All this one, there is no value that you cannot put into this x. Any value you put here, you will always get a real number. Real number does not mean that the number must be positive. Real number can be positive and can be negative. The number that are not real is the one that I have explained in our previous section, where you have something like minus square root of minus 4. In this case now, you know that no calculator will give you square root of minus 4 unless if you set it to complex number. And that is where you have, okay, square root of 4 multiplied by I. You will now have 2i. That is an imaginary number. So it doesn't mean the number, this one became an imaginary number because it is inside the square root. So it means that all the number, because we have something we call the number line. A number line is something like this. You have 0 as the center, you have 1, you have 2, you have 3, t infinity. In this place, we have minus 1, we have minus 2, minus 3, till minus infinity. All these one are set of real numbers, both the negative and the positive. So whatsoever you put into this kind of function, it will be defined. The function will be defined. Let's say, for instance, let's put minus 2. So let's put minus 2. When we put minus 2, let's say this is our f of x. This is our x. When x is minus 2, we say we are just going to have minus 2 in place of x wherever we see x. 2 multiplied by minus 2 will give us minus 4 plus 2. Minus 4 plus 2 will give us minus 2. So it means that when x is minus 2, this will be minus 2. It's not because the answer are the same. What we want to show is that we are still getting a real value, a real number. So if we put minus 1, we change it to minus 1. If we put 1, 2, 3, all of them are going to be a real number. But let's take, so if you now want to represent it, there are many ways we use to represent this type of domain, this type of domain. What we do here is that we find the domain of this function. We find the domain of this function. So, and if you want to find the domain, that's why we explain that anything you put inside this number is going to give you a defined function. So therefore, since it can take anything, our domain will now become, there are many ways we can write domain. The one I see in your book, what was there is that you can just write domain is equals to, then you open brackets and you put it there. So, but we have more than that. And the brackets you are opening and closing, all of them have different meaning. There are 2 brackets in domain. We have one like this, and we have one like this. This one is a closed bracket or closed braces, and this one is open. So it means that closed means that it's starting from that place. It's not going back. Open means that it can still go, maybe go forward or go back. So in that case now, since this one can take all the real number, our domain will just be equals to negative infinity to positive infinity. That is, if you start from here to here, any value in between them can be our domain, can be what can make this, is part of all the inputs that can make this function to be defined. So that is what domain is talking about. So we are going to take 1 or 2 examples here, and we are going to find their domain, and we are going to find the range also. So that what is range? Range is just like domain. It's just talking about the minimum and the maximum value. So we are going to see also what our range is. So let's take one of the question here, and the question is so let's take for example now, let's say we are asked to find the domain of 3x squared plus 5. Let's find the domain, and probably let's find the range and range also. Okay, so with this now, our f of x is equals to 3x squared plus 5. We have said that any function that comes in this kind of format is going to take all real number. All real number can make it to be a defined function. So our domain will just become from negative infinity to positive infinity. It means that all of them can fit into this function. So, but when it comes to range, how do we find range? So it's very easy. What you need to do is just change this f of x, change it to y. When you change it to y, is equals to 3x squared plus 5. So what we are trying to do, we want to make x the subject of formula, because x is the one we are talking about, is the input. We want to know the input that this x can be the value that we have said, that variable is just like a container. The value this container can contain and still make this function to be defined. So we want to make x the subject of formula. So it means that 3x squared can now become y minus 5. Y minus 5. So in that case, we can divide both sides by 3, because what we are looking for is x, not 3x squared. So first of all, we divide by x by 3. So we have x squared is equals to y minus 5 over 3. So we are not looking for x squared, we are looking for x. So our x will just be like, we find the square root of both sides, just like we explained. Square root we cancel square, then we have x is equals to square root of y minus 5 over 3. Y minus 5 over 3. So how are we now going to determine our range from this? What we need to know is this rule that says that negative number must not be in square root. So you just look at this. What can this y be for this place, for this everything inside this square root to be negative? So that's what we want to look for. So it means that this y must be something that when you minus 5 from it, you are not going to get negative number. We know if you say y minus 5 must not be equals to negative number. That is what we want to do. Because if this numerator has become negative, whatsoever you use to divide it, we give you negative inside the square root. And that's what we are trying to avoid. So it must not be negative. It means that if this y is 5, 5 minus 5 will be 0. This is still solvable in mathematics. If you have something over 0, can still give you something that can be determined. So, but 5 minus 5 is 0. It means if we go further, 6 minus 5 will give us 1. It's not negative. It means from 5 to up, we are going to get numbers that are not negative. So let's try and move also down from 5. So it means if we start from 4 to 4 minus 5 will give you minus 1. So it means that all the number that this y can be must either be 5 or greater than 5. It must not be less than 5, because we see that the moment we go just 1 point below 5, we are getting negative number. And we have said that negative numbers must not be in the square root. So therefore, all you have to say to finalize you have already done your domain. You say minus, from minus infinity to positive infinity. So for this one, and to finalize your range, all you have to do is that y, and you can put x at the end of the day also, must be greater than, y must be greater than or equals to 5. So you know that if y is 5 here, you are getting 0. If y is 6, you are getting positive number. That means that if you go up, you will get positive number. But the moment you come down, you are getting negative. So y must be equals to or greater than 5. And that is the range and domain of this particular question. We have other questions there, but because of time, we are not going to talk about them. So, but if you have anyone you're having issue with, you can talk to the admin to let us know. So another topic I'm seeing here is composite. Is composite of function. So after the composite of function, we also have the inverse of function. So I will take the inverse of function, then take one question also from the composite. So the inverse, what is it telling us? Inverse of a function is just like everything we have been doing. We are saying that f of x is equals to y. and at the end of the day we are getting our answer. So what inverse is telling you is that if y can give you x, then x must also give you y. So we are just trying to turn it back. We want to see what we get. What we get for f of x, can we turn it back? Can that thing also give us f of x? So it's just like reverse. So for example now, we have let's take a question here. Okay, the number one question I can see here is talking about f of x is equals to x squared plus 2. So they now want us to find the f inverse of x. So what we are going to do is that this our f of x, which is equals to x squared plus 2, we say y is equals to x squared plus 2. And we are going to try and make our x the subject of formula. So in doing that, you know, our x squared will be minus 2 will meet this one, and we plus 2 will meet this one and become minus 2. We are looking for x, not square of x. So it's going to be x is equals to, find the square root of both sides, square root of y minus 2. So when you get this, you just have to put your f inverse of x is equals to square root of x minus 2, and that will be the final answer. So that is how we solve the inverse of a function. So let me see if we see another question here so that we can solve it. So there is one, f of x is equals to x squared plus 2. F of x is equals to x squared plus 2. So we make the okay, it's the same thing we did. So let me check another one here. We have f of x is equals to we have square root of 2x minus 3. So all we just have to do is to make the f of x to be y. Y is square root of 2x minus 3. So how do we now do this? So what we have to do is to make the x subject of formula here. So how do we now make x the subject of formula? There are many ways we can go about this. Opposite. What we are trying to do here is to make x the subject of formula, but we cannot carry this x under the square root. It's not possible. So we have to remove this square root first. And how do we do that? By finding square of both sides. So if you square both sides, you will have this place to be y squared is equals to square root of 2x minus 3 raised to power 2. So this square root and this square can cancel each other. We now have y squared is equals to 2x minus 3. So in that case now, these 2x can be made the subject of formula. We are going to have 2x is equals to y squared. If this 3 minus cross will be plus 3. So it means that our x can be y squared plus 3 over 2 if we divide both sides by 2 to cancel this 2 here. So since we have this, you can just say our f inverse of x, wherever you see y here, you change this back to x, will be x squared plus 3 over 2. And that is that. So thank you. for watching. If you have any question, you can reach out to the admin on function. So the next time we meet, we are going to talk about the limit, differentiation, and integration. Thank you.